So let's start with our polynomials test review with naming our polynomials using our degree in term. Remember, degree is going to be our highest exponent degree, and the term is just the number of terms that we have when we are left. So looking at number one, the first thing that we need to do is, are there any like terms that we can combine? We always want to simplify. So yes, right here we have the negative 3a, positive 3a. Hopefully you know they canceled out, which left us with negative 3. Okay? Negative 3, no exponent, okay, is nothing more than a constant. So take a look at number 2. Number 2, hopefully you recognize the same thing, combine like terms. So we have our 7x plus our 3x. That gave us our 10x minus 4x3. What is the highest exponent value we have? You're right, it is to that third power. So we know to the third power it is cubic. Okay. And then looking at the number of terms, we have 1, 2, makes it a binomial. Now looking at 3, same steps. Any like terms? Well, there's none. So what's the highest exponent value? 3. So we have cubic. And how many terms do we have? 1, 2, 3. Trinomial. Okay. So let's look at number 4. Number 4, we are just simplifying. So here we are either going to be adding or subtracting our polynomials. Okay. So remember, before we can add or subtract polynomials, then we can only add or subtract if they have like terms. Okay. So let's see, here I have an f squared to the g, f squared to the g. They are like terms. So what is 20 minus 9? Well, that gives me 11. And then I just tack on my label, f squared to the g. Okay. When we are adding and subtracting our polynomials, okay, remember, adding and subtracting do not change our exponent values. Only when we multiply or divide. So adding and subtracting do not change your exponent values. Looking at number 6. So number 6, we are subtracting these polynomials. The first thing that I'm going to do is I'm going to distribute that subtraction sign to everything in this second polynomial. So that would leave me with a negative 5x squared, a negative 3x, and a positive 12. Okay, so that's the first thing I'm going to do. And then I'll bring down here my 3x squared plus my 5x. Okay, so that was my first thing. Now I want to look for like terms. So here I have 3x squared and a negative 5x squared. Okay, I always want to make sure that I take the sign with it. And then a positive 5x, a negative 3x. And then it looks like here my constant of 12 is standing alone. So now that I've identified the like terms, I'm just going to combine them. So 3x squared minus 5x is negative 2x squared. Positive 5x minus 3x is 2x. And then I tack on my positive 12. That is my final answer. Now, how would I name this? Well, let's see. Here's my term. We know that anything x squared, this is what we would call a quadratic because the highest exponent value is 2. Okay, there we are. So now let's look at number 5. Number 5 here, we are adding, so there is not a subtraction sign to distribute. So here I am simply combining like terms. So I start with my x squared. Do I have another x squared? I do not. Negative 3x. Do I have another like term with an x right here? Okay. There is my constants, 5 and negative 3. And then here my 4x to the third is standing alone. Okay, so now that I've identified and matched up all of my like terms, I'm simply going to add or subtract them together. Okay. When we write our polynomials, we always go from highest exponent value down to lowest and finally ending with our constant. So I'm going to start with my 4x to the third, not another like term. Okay. Now looking at my x squareds, there are none highlighted in the green. Now looking at my yellows, I have negative 3x and positive 2, so simply going to combine those. And then ending in my constants here in the red is positive 5 minus 3, that is 2. And there we go. Okay, if you wanted to name this, what's the highest value of my exponents? Well, it's a third power, so it's cubic. And how many do we have? 1, 2, 3, 4. So we would just label this as a cubic polynomial. Let's look at number 7. Number 7, the first thing you need to do is to distribute this negative 3 to everything in those parentheses, okay? So I have that negative 3 times 5x squared, just negative 15x squared, okay? Then I have that negative 3 multiplied by negative 2x. Well, negative times a negative is a positive. Okay, 3 times 2 is 6, and I tack on my x. And finally, that negative 3 multiplied by the negative 7, negative is a positive, 21. Final answer. So looking at 8, 9, and 10, we are going to be multiplying these polynomials. Now, I have shown you two methods to do that, either box method or FOIL method. Remember, FOIL is nothing more than double distribution. Okay? It is your choice, your preference. Okay? So first, number 8, I'll show this one with, I'll go with double distribution. Okay, so remember, we are going to go with our FOIL method. We're going to distribute this x to everything here. Okay, this is our first x. So x times x is x squared, and x times negative 4 is negative 4x. So I've took care of my outside x. Now I'm going to take care of my inside, which is that positive 4. Same thing, I need to distribute that to everything on the inside. So I have plus 4x, and then negative 4 times negative 4 is negative 16. So now that I have done my double distribution, I want to combine like terms. Do I have any like terms? Yes, right here. Negative 4x plus 4x, well, they cancel out. And that just leaves me with my x squared minus 16. Okay. If you like box method, still the same. Okay. I have a 2 by 2, so I want a 2 by 2 box. On top, I will put my x plus 4. On the side, x minus 4. Okay. And remember, our box is going to tell us what to do. So here to here, I am multiplying. Okay, first I'm going to multiply my boxes. So x times x is x squared. Okay, x times my 4, 4x. Okay, and now my second row, negative 4 times x is negative 4x. And negative 4 times negative 4 is negative 16. Okay. Now my box tells me what to do here. It is telling me to add or combine like terms and pull them out of the box. So I'm going to start with my x squared. There is not another x squared to combine with. Here, right in the middle, like terms. Add those together, negative 4x plus 4x, they cancel out. And finally, I am left with my sole constant right here. Okay, same answer, two different ways to go ahead and solve them. Once again, it is your choice on the method that you show me on your test. Okay, use the one that you're comfortable with. Let's look at number 9. Okay, Number 9, I think the easiest way to do this is to expand this out. So do you agree that 4a plus 2y is the same if I were to write this 4a plus 2y and do it twice? Yes, it's the same thing. So what I would do here, now that you have it expanded into two binomials, then use your method, either box or double distribution. Okay, let's just use the box method this time. I'm just going to stick to one or the other. You see, I always like to write my sign because I want to make sure that I am not losing it. Okay, so let's start. I'm going to first take care of my coefficients. What's 4 times 4? 16. And then how many a's? 1, 2. Now go across. 4 times 2 is 8. Okay. Now be careful. I have an a and a y. They're not like terms. So I just write them together like that. Go down to my second row. Same. 4 times 2, a. And I just list ay. And then my last one. 2 times 2 is 4. And how many y's do I have? I have 2. Now my box tells me what to do. Okay. Do I have another a squared? I do not. Combine my middle. 8 plus 8 is 16. And then it's just ay. Remember, I'm not combining my exponents here. We don't combine our exponents when we're just adding or subtracting. And then I'm left with 4y squared. Now, officially, when I rewrite this, I want to rewrite this from highest exponent to lowest exponent. You see, I have two highest exponents that are at the squared. So whenever that happens, I'll take it into alphabetical order. So I will be left with 16a squared plus 4y squared plus 16ay. Okay. Let's look at number 10. Okay, number 10 is just multiplying this binomial. Okay. Let's go back to the box method. I've noticed a lot of you in class like the box method. I think that's great. So here I'm going to put my x minus 3, 2x minus 5. And now I'm just going to multiply my boxes. So there I have a 2x times x. Okay, so that leaves me with 2x squared. Okay, moving on to my next box, I have a 2x times my negative 3. So we should already know negative times a positive is a negative, so I should have a negative in this box. 6 and an x. Okay, moving down to my bottom, okay, I have my negative 5 times x, and that gives me negative 5x. Okay, and my last box is my negative 5 times negative 3. Well, negative times a negative is a positive, so that should be a positive 15, and there is no variable. Okay. Here now my box is going to tell me what to do. It tells me I'm going to add or combine like terms. Starting at my upper left-hand corner, I do not have another x squared. I'm just going to pull that out of the box. Okay. Here, looking at your center, this is why I like the box method. I can just go ahead and circle these terms, remind myself to go ahead and combine them. Negative 6x plus negative 5x. Negative 11x. Okay. And then finally, my 15, just pull that out of the box, negative 15. And this is our final answer. Okay. Now, a couple of things I want to caution you of where we're going to make our mistakes. First, easy computation mistakes. Negative times a negative is a positive. Okay, we could have made it here in this last box with this negative 5 times negative 3. Okay, the other thing is when we're combining our like terms in the center, okay, negative 5x plus negative 6x, it's still negative, it's just negative 11. How can you check this? Well, you know how to factor, right? So factor this. When you factor it out, do you get these same terms? If you do, you know you're spot on. So I hope this part 1 of the review helped. Tomorrow we will work on part 2 of the review. As always, if you have any questions, don't hesitate to ask.